In this question, we're trying to find the force of gravity between a student that I've drawn on the right here, whose mass is 70 kilograms, and their teacher, who has a mass of 90 kilograms. Now, these two people are being drawn towards each other due to this gravitational force. Any two masses experience equal and opposite pulls. So both those forces will be identical as they're trying to get attracted towards each other. Now, we know from experience that that doesn't happen. The overriding force is obviously the force of gravity between us and the Earth, which keeps us sucked firmly to the ground, and friction prevents us from being pulled together. So we would expect that this tiny little force of interaction between us, this little gravitational force, would be really, really small. Now, the force of gravity between any two masses, we use our universal equation, capital G, m1, m2 over r squared, where r is the distance between the center of m1 and the center of m2, which in this case is 1.2 meters. Now, as long as our masses are in kilograms, we're good to go. So all we do now is get our calculators out and crank this out. G is 6.67 times 10 to the negative 11. Doesn't matter which one's m1 and which one's m2. They both experience the same force, equal and opposite. So I'll just start with the 90 times 70. And I divide the whole thing by 1.2 meters all squared. And you end up with a force of gravity 2.92 times 10 to the negative 7 newtons.